Efendim. Efendim. Alo. Okay, everybody. I was not available last week, and hold on a minute, just a minute, sorry. I was not available last week, so I asked the TA to tell you to watch the video. The video was about chapter 10. It was about pointers and dynamic arrays. Today I am going to go over the slides very quick, and I am going to get your questions if you have any about any of the slides. So I will be going very fast, but if you have any questions, just stop me and ask me your question. This chapter was about pointers and dynamic arrays. We actually know about pointers and dynamic arrays, and we know how to use them in C, but we like to use the same techniques in C++ because we know that they are very powerful. In C, we used to use these two functions to allocate space, memory allocation function, and this is for returning the space that we have received. For C++, we can do the same thing, but this time now we have two new operators, okay? New and delete, okay? These are two new operators. These are functions, okay? Function means that it is not part of the language, but it is part of the standard library. These are part of the language, okay? C++ adds two new operators, the operator new and the operator delete, and we talked about it. And if you remember, this was the header declaration of the memory allocation function malloc. It takes an unsigned integer, size of the memory to be allocated in bytes, and it returns a void pointer. And if you like to allocate a space for an integer, and this is what you used to do, right? So if you are not familiar with this kind of C notation or C memory allocation technique, then you should go over your notes and you make yourself familiarized with the C memory allocation stuff. Okay. With this chapter, we said that we are going to use the pointers and dynamic arrays and classes and pointers and etc. Okay, and this was a nice example. At the beginning, we said that pointers are like new types, okay, like integers or doubles. If I have an integer a, it has a memory in the, it has a space in memory, okay, and I can initialize another one like b. The first value of b is 7. It is initialized. Let's say these are the addresses. 1 is address for a, okay, 3 is for address b. Who question? When I say integer a, b, okay, double d, I know that I make a decision on the name of the integer, okay, a. I make a decision on the name of the integer b. I know that too. I make a decision on the initial value. I make a decision on the type, but I don't make a decision on the address of the variable. What is the address of A? What is the address of B? What is the address of D? Okay, I don't make that decision. Who makes that decision? Who makes that decision? Computer is not a very good answer. No, compiler is the correct answer. Yes. Okay. Compiler makes that decision. Is there any way in C I can move my integer from one location to another location? For example, in this case, the address of A is 1, address of B is 3, address of D is 7. Oh, of course, these are imaginary addresses. The addresses are not like these small numbers. They are large numbers, and they don't have to be like 1, 2, 3, 4, 5, okay? If I like to move my integer from this position to, let's say, this position, can I do that? The answer is no, it is not that easy. Of course, in C, everything is possible, but no, it is not that easy to move my integer from one location to another location. So it is out of our hands where my, almost out of my hands where my integer is located in the memory. So it is decided by the compiler with the help of the operating system. Okay, so when I do this, when I say I have this A, B, and D, compiler puts them some place in the memory. Okay, when I say the same thing, I have an integer pointer. Okay, compiler say that's okay. Your integer pointer is going to be here. Okay, and with the integer pointers, there are addresses, right? All I can do is with the integer pointers is store addresses. How do I do that? Here I say that, okay, take the address of A and put it in the position of P2. Okay, so there is no type mismatch. As like here, there is no type mismatch. B is an integer and it takes an integer. D is a double, it takes a double. P2 is an integer pointer and it takes an integer address. And I can do this assignment too. I can do this assignment too. So what we are trying to say in this slide is pointers are like regular types, like integers or doubles. There are certain things that I can do with integers, like addition, okay, or assignment, or subtraction, whatever. And there are certain things that you can do with the pointers, like the assignment, okay, like the assignment. So what I'm saying is, don't take pointers as like complicated types. They are not complicated. They are just different types, like integers and doubles are different, right? I mean, I cannot do the same thing with an integer that I'm doing the things with doubles, right? So they are different types, integers and doubles. I am not saying that doubles are more complicated than integers. All I am saying is that they are different. Okay. So this is what we meant by this slide. And I think this was a nice comparison table. It said that, okay, you say that with a double, an integer, and an integer pointer, what kind of things can we do? Okay, with a double, there is a binary plus operator, there is a binary minus operator, okay, there is a binary multiplication operator, there is a unary minus operator, right? With an integer, again, there is a binary plus, binary minus, assignment operator, assignment is valid there, okay, and binary multiplication, unary minus, and modulo operator, right? Remember the modulo operator with the integer. Modulo operator is not good for the doubles. With an integer pointer, I have binary plus, okay, and I have binary minus. Assignment, of course, assignment is always binary. Assignment is always binary. There is no unary assignment operator. And unary the reference operator with the pointers. Okay. Nejdet is saying something. I don't know what he says. Are you asking a question? Nejdet, you cannot say void B. There is no, you cannot have a void type. What is yes, Nejdet? You can have a void B type, but I cannot. Nejdet, why don't you ask it using your microphone? I don't understand what you are saying. What is yes? But I cannot write. What do you mean, but I cannot write?
Sir, if I declare a void a pointer, when I equal a integer, what söyleyemedim. İşte hocam bir tane void
Well,
pointer olduğunda onu integer'a nasıl hesaplayacağım?
both of the lines that you are writing here, okay, this is not correct because address of A is not a pointer. Okay, so you cannot do that. And this is not possible either because type of a variable cannot be void. It has to be void pointer. Okay? If A is an integer, then address of A is an integer pointer. You cannot assign an integer pointer to a void. Do you mean a void pointer? Why don't you write up your question and send me an email? Okay. So this is what we said at the beginning of the lecture. Pointer variables are regular variables, like integers and doubles, and there are certain things that you can do with integers, and there are certain things that you can do with the pointers. Okay, that's what we said. I'm going very fast. This was a nice example. Well, it is not that nice, but it is an example from the book. Remember this one? And I think I have some code about it. Okay, we are gonna go talk about it. But the book says that while we are talking about the pointers and integers and etc., we keep talking about the addresses, and we keep talking about like this. Okay, we keep talking about P1, P2 holds the address of A. Okay, P2 holds the address of A, which is 1. I write 1 here, right? And when I do the assignment, assign the value of P2 to P1, this becomes 1, 2. So the book says that when you talk about the pointers, you don't really, what is happening is that we are storing addresses, okay? We are storing addresses, and we are manipulating addresses, right? That's what we are doing. But when we talk about the pointers, we don't talk about addresses actually. We hide that fact, okay? Instead, we use these arrows. We say that P2 points to A, okay? P1 points to A. So we don't put these addresses here, right? We don't write them. Okay, that's what the book says, and that makes it easy to talk about the pointers. Okay, so we talk about pointing, not addresses. We say that, okay, A points to, it is okay to have, when I say integer A, the value of 7, we say that this is A, okay, and when we say integer pointer P gets the address of A, okay, we just do this, P points to the A, okay, that's what we do. We talk about pointing, not addresses. That makes it much easier. to talk about the pointers. Okay, so we are going to talk about this line again. I think there is a program from the book. Okay, so you watch this from the video. I am not going to talk about them, but I am going to talk about the program like this one. Okay, so here I have, why don't I redo the same thing? Okay, here I have, okay, it says that I have a pointer named p1 integer pointer, another pointer named p2. Okay, let me go to the program here. Okay, this is much better, right? Let's say I have a function f. Okay, in this function f, let me erase these. Okay, let me erase these. In this function I have two pointers, p1 and p2. Okay, I have these two functions, p1 and p2. When I say new int, okay, the system is going to give me a position in my heap that is sufficient for a storage of an integer. Let's say the address that I get from this new int is 1017. This is the address of this new position, and I am assigning this address to p1. So p1 is pointing to this location. So line 8, this is done by line 8. Line 8 draws this arrow. Okay, this is done by line 8. Okay, and in line 9 I say that in p1, okay, when I say, of course, the book says that don't use addresses, but for the sake of clarity, I am going, sorry. This is 1017. Okay. With the line 9, okay, with the line 9, there is a dereference operator. The reference operator says that take the address 1017, okay, go there and make it an L value. Now it's an L value. Since it's an L value, I can use it for a assignment operator and put 42 in there. So this 42 is put there by line 9. Okay. How many operators are there in line 9? There are two operators. One of them is the dereferencing operator. The other one is an assignment operator. Dereferencing operator works on the pointers. How about the assignment operator? What kind of assignment operator is this? The assignment operator works on pointers or integers? Yes, it works on integers. Why? Because 42 is an integer. Dereferenced p1 is an integer, L value. Okay. So I do that. So line 9 puts this 42 in there. Let me use another color. Okay, let me use green and say line 9. Okay, line 9 does that. And then I have line 10. Line 10 says that, okay, do this assignment. Okay, get whatever P1 holds and put it in P2. So what is in P1? In P1 I have 1017. So P2 becomes 1017. That means that I am putting another arrow here. This one is pointing to the same location. So this is done by line 10. Okay, so line 10 does that. Let me use the same color for this one. Line 8. Okay, so this is the picture. I think I did this before in the video last year, and I did it again. I am not doing this just to repeat it. I am doing this if you have any questions, maybe there is a good opportunity to ask these questions. Okay, and by the way, I didn't say much. I didn't say many neat things in this slide. In terms of C++, all the only new thing that we did here is this new int thing. Okay, and it's a very simple addition. Without the new, I could have done the same thing with C2. So I didn't. These are all C stuff. That's what I am trying to say. Okay. So if we continue, there is this dereference P1 and dereference P2. Okay. Get the value of, take this address 1017. Okay. And go to this address and get this value and print it out. And do the same thing with P2. P2 ends up at the same address and prints it out. So this one will print out 42. This one will print out 42. When I come to 13, line 13, it says that get P2, dereference it here. Assign 53 on it. So read this and do 53 and print them out. Okay, and I think the other slide is okay. With the other slide, I am getting a new integer now. Get a new integer to P1. Now this P1, let's say it is 1067, and make this assignment. Okay, so this is the last time what we did, and I think I'm not going to spend too much time on it. Are there any questions? It is okay to ask questions. Ask me questions. Okay. If there are no questions, then I am going to maybe just you can write the same program and do it yourself, just to see what's going on. Okay. The new operator again creates new dynamic variable and it returns a pointer to the new variable. Okay. And doesn't matter what kind of type it is going to be created. Okay. It is okay to say new integer. Okay. When I say this is my memory. Okay. When you say new integer, okay, an integer pointer P1 gets the value of new integer. This is P1 and this is a new integer, and this is what happens. When you say money pointer M1, okay, new money, and let's say $10. Money is going to be there. This is my money, and this is my M1, and this is going to point there. Okay. Question. This is the position for an integer, right? P1 points there. And this is the position for money. Okay. Which area is larger, green or red? Which area is larger, green or red? Why? Why? Because the red holds the money object, and inside the money object, if you remember, there is a dollar part and the cents part, and each one is an integer, right? Green part is just an integer. So I expect that the red is larger. Okay, red is larger. So let me ask you another question then. Do I have a third color? I don't have a third color. Okay, if I don't have a third color, then maybe I should just erase these. Okay, same question. Which area is larger, green or red? The area for P1 and area for PM1. Which one is larger? P1 is a integer pointer, M1 is a money pointer. It is exactly the same. Yes, it is not red because the pointer for a money object and the pointer for an integer has the same size. They are addresses, right? Remember what are the pointers? Pointers are addresses, right? They hold values. Let's say this value is 1071. This value is 2011, right? So what I do is here I have 11 and here I have 1071. Okay, so the addresses are the same size, because they are just addresses. What is the address for Gebze Technical University? It is Gebze Technical University. I think it is Cumhuriyet Caddesi No 20 Gebze. This is the Gebze address for the Gebze Technical University, right? And the Gebze Technical University is very large, maybe 600 dönüm place, very large area, right? So what is the home address of my friend in Pendik? It is Mr. Ahmet Ali Gazi Caddesi No 21 Pendik. And this is just a 100 meter square home, right? So what I am trying to say is that doesn't matter how large the position is, the addresses are very similar. I mean, very large university campus address and very small home address. Okay, it is very similar. P1 and M1 have the same size. Okay, P1 and M1 have the same size. So, but in that case, can I do that? If their sizes are the same, can I do this? P1 gets the value of M1, because in that case, if P1 gets the value of M1, so this is 211 and this is okay. P1 gets the value of M1. In that case, what am I gonna do? Erase this 211 and no, just the opposite. erase this 1071 and write 211. Can I do that? Can I do this? Can I do this assignment? Logically, you like to say yes, but C++ doesn't let you do that because integer pointers and money pointers are two different types. And in C++, when you do the assignments, the types should be compatible with each other. They are not compatible. No, you cannot. In C++, you cannot do that. You are not allowed to do this. Okay? If you do that, that would be a very big problem. Why? Because you are pointing to a money object using a integer pointer. And with the integer pointers, you can make integer assignments. When you do the integer assignment to a money object, that's not going to be a good thing. That's going to be a bad thing. Okay. In C, yes, you could do that. But in C++, you're not going to do this kind of an assignment. Okay. No, you cannot. So that was important. Okay. Try doing that. Okay. Try doing these kind of assignments and what you can do and what you cannot do. And if you like, you can force it to be assigned using the typecasting operator. And do that kind of wrong assignments using the typecasting operators, and you will see that nothing good is coming out of it. Okay, do these experiments. Okay, so more on new operator. Okay, doesn't matter what you have here, integer or money or something else. It will give you some space in your heap, in your memory, and you will get the address of it, and you will do this assignment. There is a class named myClass. These are the parameters for the constructor. You get the pointer and you make this assignment. Okay. With the pointers and functions, it is like sending a double to a function, sending an integer to a function, sending a money to a function. It is almost the same thing. Instead of sending a money object to a function, I am sending an integer pointer to a function, and I can return an integer pointer from functions. No problem. Okay, so we talk about when you use new operator, we get some memory from the system. Okay, where is that memory? That memory is not a stack. Okay, it's a special place called heap or free store. Okay, so that space is reserved for dynamically allocated objects. Okay, when you use the new operator, the memory comes from this position named heap. Okay, usually your computer memory is organized like that. Okay, let's say this is your memory, whole memory. At the beginning you have your operating system, memory for the operating system. Let's say this is my program 1. Okay, at the beginning of the program there is my code. Okay, all of my code, runnable code. Then I have some space for heap, and I have some space for stack. This is heap. Okay, and this is the stack. Stack is used for local objects, and stack is automatically arranged for you, automatically managed for you. Okay, but heap you have to manage it yourself. When you take a new space from heap, you have to return it back using the delete operator. Or when you take some space from the heap using the malloc function, then you have to return it using the free function. Okay. That's what we said last time. C++ 11 edition for the pointers. Remember the null pointer? It is defined like an integer, define null 0. Okay, that was the definition of the null pointer. we don't like this definition in C++ because 0 is an integer. Okay, I don't want to intermix the integers with the pointers, because let's look at these two functions. These two are valid overloads. One of them is taking a integer pointer, the other one is taking a integer. If I call this function with a value of 0, which one am I calling? I mean, 0 means, okay, integer, but 0 also means the null, right? So it is confusing. That's why C++11 says that no, I am not going to use this null anymore. There is a new constant called Null Ptr, this one. Okay, Null Ptr is used to indicate the null pointer, and it is not 0, it is not integer. So when you call that function with Null Ptr, okay, it is definitely the first one is going to be called, not the second one, because Null Pointer is a pointer. It is not an integer. It is not defined like this. Okay, so in C++11 we don't use this define null. Instead we use this null pointer, and null pointer is part of the language. Okay, it is not addition by the standard library or anything like that. Okay, I think we talked about this last time. If you do this, okay, if you have an integer pointer and I get a new integer, sometimes you may be out of space in your heap, so you have to make this comparison. If the pointer that you get is a null pointer, that means that you are not successful in getting the memory. You don't have enough memory. So if you don't have enough memory, what are you gonna do? There is not much you can do, because you are out of memory. Most of the time you will say, I cannot continue, I will quit. That's what you do. Okay, this is one way of comparing it. There are ways of automatically terminating your program, or there are ways of producing exceptions, and we are going to talk about it later. Okay, the free store is usually very large. Okay, and usually we don't use that much space, but it is a good practice to write code like this. Get some memory, compare it with null pointer, and if it is not null, then continue, otherwise terminate. Delete operator is the same as the free function in C++. Okay, whenever you do a new, okay, you have to delete it. Whenever you do a new, you have to delete it like this. I have an integer pointer, I get a new integer of value 5, okay, and do some stuff. When I am done, I delete this p. I think I talked about this last time. So what would this one print on the screen? What would this line, the line that I'm pointing now, would print on the screen? Okay, so out of 70 people, how many people do I have here? Out of 95 people, only 3 people are telling me it is 5. Okay, good. Yeah, it would print 5 on the screen, and for some reason Merve says it is garbage. Why do you think it is garbage? I mean, I am saying it is. Why would it be garbage? This would be exactly the this would be the picture. I mean, this is P, and when you do the new integer, I create this location whose value is 5, and I do this assignment. Now if I dereference P, it will reach here, it will get the value of 5, and it will print out on the screen, right? Okay. Osman, I am not asking. Okay. I ask what would this line that I framed with green print on the screen? Okay, I think there is a synchronization problem. Okay, I am not asking about the red one. Okay, I'm asking about the green one. Green one, 5 on the screen. Then after delete P, okay, tell me what happens after I execute this delete P. When I say delete P, how does this picture change? When I say delete P, how does this picture change? This picture stays exactly the same, yes. Okay. It just gives this memory location back to the system, and system doesn't do anything about it, anything about this 5 or anything about this location. But that location doesn't belong to me anymore. Okay, that location doesn't belong to me anymore. So P is pointing to this location, and probably the value of 5 did not change. I don't know. That location is not mine. Okay, so I don't know what happened to 5, but P is definitely pointing to that location. After that, I ask this question: what would happen if I execute this line, the red line here, cout P? In that case, most of the time it is going to print 5. Okay, most of the time it's going to print 5. Sometimes it is going to print garbage value, and sometimes I am going to get a segmentation fault. Okay, that's a very bad error actually. Trying to use some space that doesn't belong to you. Green is okay, red is not okay. But I bet 99.99% of the time you're gonna get the value of 5. But when you send this code to your client, you get their money, $5 million for a piece of software, and when they run your code, and once in a while they are gonna get a segmentation fault, and it's going to be very difficult to find this kind of a problem. So what do we call this problem? What do we call this problem? The problem that I am having with the red line. Dangling pointer. Yes, dangling pointer. That means that a pointer is pointing to some place that doesn't belong to me. Dangling pointer. Okay, this problem and this problem is exactly the same. Let me write this code here. Cout, okay, P. Again, right after I make this integer pointer, without initializing it, okay, without initializing it, I try to print out the dereference version of it. Okay, let me write this actually. Maybe, where should I use it? Here. Okay. Okay, let me see out P1, see out the referenced P1. What is this? What would I get with this one? Line 9. Is this a bad thing, good thing, what? Well, let me tell you, both of them are bad things. But what kind of bad thing is line 9? What would I get with line 9? Garbage value. Probably 0, which is a garbage value. I don't know. Okay. Garbage. Okay, it is probably 0. Because I did not initialize it, right? I did not initialize it. How about this one? What would I get with this one? Yes, Yunus Emre, exactly. It is segmentation fault or garbage value. Okay. When is it a segmentation fault? It's a segmentation fault if if P1 contains address of some place that belongs to me by accident, right? By accident, I am going to get a garbage value, and by accident, I am going to get a segmentation fault. Okay, segmentation or garbage. Okay, so this is important. This is important. Probably because people are getting segmentation faults with the pointers. Okay, they are saying that pointers are difficult or kind of like that. But this is no different than saying integer I, okay, and cout I. This is no different than same as line 9. Okay, this is like line 9. It will print garbage. Most of the time it's going to be 0, but 0 in that case is a garbage value because I did not initialize it. Okay, try these and see what kind of things you are getting. And as I said before, it's not going to be the same all the time. It will change from time to time. Okay. Let's take 10 minutes of break. After the break, we will continue. Efendim? Merhaba. Nermin Hanım, benim bu telefonda problem var ya. Oradan eksilteceğim. Bir de başka bir düzeltme daha yapacaktım ben. CNF'ye. Evet. Anlamadım ki o zaten danışmanlık hali. Yani başka bir üniversite yapacağım akademik danışmanlığı onların içerisine koyamıyor muyum acaba? Her neyse tamam. Başka ne var Nevzat'ın ya? Ben öyle okumadım ben. Vallahi onların diğerlerini düzelsek iyi olur. Çünkü o başımıza yine dönüp gelecek. Bir daha baştan döneceğiz. Yani bulalım onları değiştirelim bence. Yani onları başarılı. Hı hı. Onu bilmiyorum ki ben. Onu gerçekten bilmiyorum. Yani onlar yine DD falan olsun ama geçmiş öyle ama işte diyor yani başarılı kabul edilmesi diyor değil mi? Öyle bir görüş istiyorlar bizden. Tamam yani şey diyebiliriz onlara diyebiliriz ki biz eğer kabul ediyorsa dekanlık bu öğrencilerin notları DDDC'dir ama başarılı kabul edilmiştir. Yani o şeye ön şarta takılmasınlar. Diğer türlü ortalamalar artacak yani şey kafadan. Yani bu DDDC'leri CC mi yapacağız? Yok yapamayız ki. CC değil onlar. Göndermiş. Tamam yani biz diyeceğiz ki bu durumda bu öğrencilerin DDDC'lerinin ön şarta ön şarta takılmayacak şekilde başarılı ya da işte yönetmenin şu maddesine takılacak şekilde başarılı sayılması uygun görmüştür diyelim biz. Onlar ayarlasınlar. Diğer türlü DDDC'sini CC yaparsak CC'lerini BB mi yapacağız? Yok değil ki öyle yani. Tamam işte öyleyse bunları geçerli kabul edilmesi diyelim o zaman. Uygun bulmuştur o kadar. Bir daha intifak yapmayalım. Tamam. Teşekkür ederim. Eğer şeyse idare edemeyecek durumdalarsa Fikret geldiğinde bir söyle onları ya. Ben dedim mi ben sana bir şeyler hakkında endişelenip duruyorum diye. İnsanın kafasını bozuyor bu, endişe yaptırıyor böyle. Böyle ufacık bir şeye kafana takıp büyütüp. Şimdi bak sen sürekli söylüyorsun ya ne olacak da bana hastaneye gelmeseydim şuydu buydu falan da falan. Yok yani bu kadar millet alıyor, geçiriyor, şu ne diyor, bu ne diyor değil mi? Yani öyle endişelenecek bir şey yok. Bir çaresi bulunur hepsinin. Seninki bulunur, Erdoğan Hoca'nınki bulunur, onlarınki de bulunur. Yani burası dağın başı değil. Bu hastalık yapıyor o tür şey, endişe yapıyor. Ben şimdi ne yapacağım, nerede ne yapacağım, gideceğim, bunlar hastaysa ne olacak falan. Lüzumsuz bir şeye takılıyorsun böyle kafana, tamam mı? Ya bu lüzumsuz değil tabii ama yani çözüm olabilecek bir şeye takıyorsun, kafanı büyütüyorsun. O iş şeylerden bir tanesi o serpmalarla. Hala var bende böyle ufacık bir şeye takılıp ne olacak falan filan diye içinde. Anlatıyordum ya ben sana. Yani ona düştüğün zaman o aklına gelsin hep. O bir böyle vesvese veriyor insan içine böyle bir. Evet. Evet. Çaresiz diyor ya senin kardeşlerin var, hanımının kardeşleri var, şunlar var, bizler varız, yardım ederiz yani hiç korkma o konuda yani. Hı? Yani takma o kafana. İnşallah onlar da atlatırlar. Yani bizden kardeşim benim de kötü atlattı ama evdeydi. Yani hiç hastaneye gitmedi. Bir tek Fikret yaptı. Benim kardeşim hala yatıyor. Seninle beraber başladı o. Hala evde yatıyor. Bir türlü yani bir düzgün kalkıp da yürüyemedi. Şimdi tam sonuna kadar bir de çekemiyor. Film falan çektiler. Yok hayır evdeydi. Hastaneye gitmedi o kadar. Sonra da ayrılma hayata geçirdiler. Yani sen bir iyileş, bir kafanı tut, serin tut birazcık. Hallolur. Hı. Tamam oldu hocam. Ben şimdi tekrar derse gireceğim. Yine görüşürüz inşallah. Sen de sensin yani. Ne yapacağım? Kimse yok. Ne yapacak mısınız siz? Gelin diyorlar yani. Hı hı. let's go to the slides again. So the delete operator is doing exactly the same thing as the free, and the delete and new kind of behave differently when we work them with the arrays, but we are going to see the arrays in a few minutes. We talked about pointers. Usually, not to have a dangling pointer, for not having a dangling pointer, we do this. After deleting a pointer, we assign a null pointer to it. Okay? In this case, when you do this, okay, this is definitely a segmentation fault. Okay? There is no garbage. Okay? This is definitely a segmentation fault. Why? Because this is null pointer, and null pointer is definitely not yours. This value is 0. Address 0. Address 0 belongs to the operating system. You cannot access to it. Okay, you cannot access it, and that's why we like this better, because I mean this is again a dangling pointer problem, but again, every time you run this, you're going to get a segmentation fault. At least you're not going to get garbage value, or sometimes by accident a correct value. Mehmet Avni has a question. What is the difference between free and delete? Free is a function. Free, we don't use free in C++. Delete is an operator, okay? Free, what is the, okay, let me go to the slide number 1. Okay. Malloc is a function. It takes the size of the allocated memory, and it returns a void pointer, right? So what does free take? What is the parameter for free? What does free take? What does the function free take as the parameter? Pointer? Not a pointer. It just takes a void pointer, right? It takes a void pointer. And I am not sure what free returns actually. Does free return a size? Free returns what does free return? I don't remember. Maybe it is void. Free, yeah, it is void. It takes a void pointer and returns void. It doesn't return anything. Okay, this is a function. It takes a pointer and it returns nothing. Okay, this is a function. It takes an integer, it returns a void pointer. New is not a function. New is a operator. Okay, new is an operator. Since it's an operator, it takes a type. Okay, this one takes an integer. New takes a type, and it returns a pointer of that type. Delete takes a pointer, okay, and it doesn't return anything. Okay, it doesn't return anything. So in C++, we don't use malloc or free. We don't use them at all, okay, because malloc and free, they don't know about the types. But C++ is a strongly typed language. Whatever you do, it has to know about the types. Okay, new and delete know about the types. Free and malloc, they don't know anything about the type. All they know is size of the area and getting and returning void pointers. Okay. Atakan says that what is a void pointer? What is a void pointer? Okay. I drew where is my, remember I drew a picture. I asked you about the size of the areas, which one is larger kind of stuff. Where is it? Yeah. Okay, I think it is here. Okay, let me erase this part here. These. Okay. Okay. Let me, first of all, when you say void v, this is a compiler error, right? You know this. This is a compiler. You cannot have a variable named variable of type void. But when you say void pointer vp, this is not a compiler error. And in your memory, okay, in your memory, there will be a position for vp. Okay, somewhere in your memory, there will be a position. Maybe let me put it in here. Okay, vp, and its initial value will be garbage. Okay, so this is a pointer. So what kind of things can I point to with this void pointer? Any kind of stuff I can do. I could do things like vp guess the value of void pointer, okay, address of or I could do this, sorry, or I can do this, m1 is a money pointer, right? Or I could do vp guess the value of p1 is a integer pointer. So void pointers can have addresses of any object, and it's a very useful thing for C, because in C we are not very careful about types. Okay, so with the help of the void pointer, I can do any kind of assignments that I like. In this case, I can, if I like, I can assign an address of a money object to an address of a integer pointer using the void pointers. Okay, in C++ we don't like void pointers, because void pointers leave the task of type checking to the programmer. Okay, I don't want to do that. In C we have to do this, because in C we have stuff like, we have functions like free and malloc. Okay, free and malloc doesn't know what kind of pointer it is returning. It just says that it's a memory location. Use this as you like. In C++ we don't do this kind of stuff. In C++ when we return a pointer, we know its type. We don't return any void pointers. So in C++ we don't like void pointers, but in C we like them a lot. Okay, that doesn't mean that void pointers are not important. They are very important to understand what's going on with the pointers, especially for C. Okay, they are important for C++ to understand what's going on with the pointers too. Okay, but in C++ we don't use void pointers much. Okay, I think I was at this 28, yeah. Okay. Ennis has a question. Why can't delete operator set null pointer in pointer it deleted? Because it doesn't have to. I mean, that's an extra thing. That would take some CPU time. And if I don't want to do that, that would be a waste of CPU time. And it says that to avoid any dangling reference problems, why Why don't the delete operator do this for us? Well, I mean, it is up to you. I mean, it's the same as this. Why doesn't the compiler initialize this I to 0, right? Okay, why this I is not initialized to 0? Can you tell me why? It is not initialized to 0, right? Because sometimes it doesn't make any sense, because after that I do this. Why would I initialize it to 0, then I make this assignment to 5, right? So it is a waste of CPU time. With the delete, it might be the same thing. Okay, so dangling pointers and that kind of dangerous stuff. I mean, watch the video again. I talked about this last year and it is in the video. Okay, new and delete are in IO. No, Muhammad Bedir. New and delete are operators. They are part of the language. See, when I say new int, okay, this new is blue. It's like using a namespace. Okay, it's like for, okay, for loop, right? See, for is a part of the language, right? New is part of the language. They are not defined in any headers. It is part of the language. Okay. So there is a header called new, but there is, I mean, inside that header there are some other stuff. C++ new header. Okay. Inside the new header, you don't have definition for an operator. Okay. You don't have definition of the new and delete operators. I don't know what's going on with here. Let me find it some other place, maybe this one. Where is my new header standard? Okay. Okay. Inside the new header, okay, there are these classes, bed allocation. That's the when you do the allocation, there is not enough space. Okay. That kind of stuff. Okay. And as you remember, new is an operator, delete is an operator. With the operator overloading, it is possible to modify them, but usually we don't touch them. Okay, we don't touch them. Good. Do I have any other? So we can overload new and delete? No, you don't touch them. I mean, overloading them is not a good thing. New and delete. You usually don't prefer. Remember, sometimes some of the operators are not overloadable. Some of them we don't touch them. Okay, usually we don't touch them. Okay, are there any other questions? What's a void pointer? Why can't delete? So we can overload new and delete. Last year you said class A is your favorite class. Can you explain why? Okay, class A is okay. Anil, I didn't say that last year. I repeated this many times this year too, and the reason why I say empty class is my favorite, because when you have the empty class, that class is not an empty class actually. It has lots of things in it. One of them is the assignment operator. The other one is the default constructor. Okay, there are many things defined for the objects of that class, and it is important to know what those are. And we are going to talk about it today too. Okay. Okay, let me go back to the, okay, we talked about the dangling pointers and dynamic and automatic variables. Okay, automatic variables are, let's see if I have this. Okay, here A and B are automatic. Why do we call them automatic? Because when you create them, they are automatically killed when their scope is out. They are automatic because they are killed automatically. Okay, this A and B will be killed here. This K will be killed here. Okay, their deletions will be done automatic. They live in the stack. Since they are automatic, we like to use them as much as possible. But if we need to have a variable that has to survive after the function ends, then what are we gonna do? Then we are gonna do this. We are gonna say that, okay, integer pointer p gets the new integer. Okay. Question: is p an automatic variable? Yes, p is an automatic variable, but the place that p is pointing to is not automatic. Okay, the place that p is pointing to is not automatic. When this function ends, p will be killed, but the space that I've created with this operator new int will not be killed. It will survive. Okay, so if this function ends like this, it's a bad function. Why? Because I have created some space and I did not delete it. So that's going to be a memory leak. So what would be the best thing? It is either like delete p before p is killed, or maybe I could do this. Maybe I could do this. I could return a integer pointer and I would just return p. If you return p, p will be killed, but the value of it will be returned, and whoever is calling this function f could use this new space and delete it later maybe. Okay, so we like automatic variables and use automatic variables as much as possible. Don't try to use dynamic variables where automatic variables are suitable and convenient. But for some cases, sometimes automatic variables is not enough, because after the function ends, you like to continue using some space, and this is going to be needed when we do classes like the vector class. Okay, and there is a good example in this chapter, and we're going to look at it in a few minutes. Okay, so local variables are not dynamic. Okay, they are called automatic, and they are declared within function definitions. Okay, but dynamic variables, they are created with the new operator. For every new, there should be a delete, and it is up to you. It is your responsibility as a programmer to do the delete for any new operators that you called. Okay. Okay, so book says that sometimes these pointers are making it difficult to understand or unreadable. So sometimes if you like to use an integer pointer, do this type def. Okay, do this type def. Type def doesn't create, the name type definition is not a good name actually. This is not a new type definition. In C++, type definitions are done by this class keyword, or classes. Okay, classes create new types. Okay, type definition gives this one a new name. Okay, so this when I do this type definition integer pointer, when you say let's say, let me modify this a little bit. This is P1 and this is P2. Okay, after doing this, I could do this assignment. P1 gets the value of P2. This is okay. Why? Because this type and this type are exactly the same. Okay, they are just two different names. Defines a new type alias. Okay, defines a new type alias. Do the same thing with this class definition. Class A has an integer in it and a constructor. Class B has an integer in it and a constructor. They look exactly the same. Their names are different only. Okay, their names are different. When you make objects of class A and class B, you cannot do this assignment. Although they look exactly the same, they are other than the names, they are exactly the same. No, you cannot do this. You cannot do this. You cannot make this assignment. So these are two different classes, but these are not two different types. So when you say type def, it is not actually new type definition. It's just giving another name. The two are equivalent. Okay. So we already know about the call by value pointers. Okay. And I am not going to talk about them because you already know from C. If you have any question, you may ask now, but I'm going to skip them. Dynamic arrays they are possible with C and they are also possible with the C++. So how do I make a dynamic array? This is how I make it. When you say I have an integer array of size 100, what is A actually? A is a constant pointer, right? A is a constant pointer, integer pointer. The type of integer A is it is integer pointer const A. Okay. So A is a constant. You cannot change A, but its type is integer pointer. I know that, right? I know this. So integer it's a pointer, but it's a constant pointer. You cannot change it. I like to do this integer pointer. Let's say a array new integer, but with this integer I need 100 of them. So what is the picture here? The picture is like this. ARR is a pointer and there is a space for 100 integers. Okay, and this one points to here. There are 100 integers in it. This is the notation. This is how you create dynamic arrays in C++. How do we do dynamic arrays in C? Can you write the same line in C? Okay, this is C++. I'm going to write the same line in C. It's going to be like this. Integer pointer ARR, and I am going to say malloc. Okay, memory allocation. I need 100 integers, space for 100 integers. Size of int. Okay. And to make it more readable and okay, put this integer pointer typecasting in there too. So this is C. C++ and C. Okay. The picture would be exactly the same. Both pictures would be exactly the same. Okay. When you look at this one, malloc doesn't know about the type, but ni knows about the type. Okay. Malloc doesn't know about the type, but ni knows about the type. Ni knows that it is creating space for 100 integers. Malloc doesn't know that. Malloc knows that it is creating space for 100 times, let's say 800 bytes of space. That's what malloc knows. Yunus Emre, yes, sizeof is an operator in the C language too. Okay, sizeof is part of the language again. Sizeof. See, when I say sizeof, new, delete, okay, these are all parts of the language. Cout is not part of the language. See, the editor knows about these. Okay, these are all operators defined in the language. Cout is not an operator. Cout is not part of the language. It is part of the standard library. Okay, good. Atakan says, how can we do the reallocation? I am not exactly sure what you mean by reallocation, but I think you mean this space is not enough anymore. I like to allocate 200 integers now. We are going to see, we have a nice example and we are going to see it. Okay, so here the very similar example that I gave you. I am not going to talk about it again. This is a good slide. I have a array A. A is a pointer, but it's a constant pointer. And I have a integer pointer P. I could do this assignment, but I cannot do this assignment. Why? Because P is an integer pointer, but non-const integer pointer. A is an integer pointer, but it's a const integer pointer. I cannot modify the value of A. Okay? I cannot modify the value of A. So this is important. Understand this. Okay? So this is the type of A, integer pointer const. Okay, so dynamic arrays, we like them a lot because with the non-dynamic arrays, the size is fixed. I cannot increase them, decrease them. I cannot reallocate them. So we are going to do dynamic arrays, arrays that can grow and shrink and change their sizes. And this is how you do the dynamic arrays with C++. Okay. One thing that you need to be careful about is when you do this, okay, when you create a double array of size 10 and assign the pointer to this double pointer, when you delete this pointer, you need to delete it with this the curly, you need to delete it with the square bracket operator. Okay, so this is a new operator. This is a operator delete, but it is special for the arrays. If you have created some space with the, on the heap, then you need to delete it using this notation. Okay, that's how it is done. Why we are doing this? Because you are telling the compiler that you are not deleting a single object, but array of objects. You have to delete all of them. Instead of doing this, if you use the regular delete D, okay, only the first object of the array will be deleted. The rest is not going to be deleted. Okay, good. Pointer arithmetic, we already know about them. I am not going to talk about it because you know about them. And last time, the video that I pointed to talks about it. I'm not going to spend much time about it. Later, maybe, oh, there is a problem here. The problem is this. Okay. Okay, so I am not going to talk much about it. Multidimensional arrays, maybe I can talk about this a little bit more. Okay, yeah, let's talk about this. Maybe you'll ask questions while I'm talking about it. Multidimensional arrays, remember multidimensional arrays. How do we do multidimensional arrays in C or C++? You already did that. Okay, this is how you do it. Let's say I have a integer array 10 and 10. Okay, how does the memory look like if I do this? The memory looks like this. Okay, ARR, it will contain 10 times 10, 100 integers. Okay, inside this 100 integers, this is ARR1, and there are 10 integers here, 10. Okay, and this is ARR2 and 10 integers here too. Okay, and this is ARR. I am sorry, I did a mistake here. This is 0, this is 1, and this is 9. Okay, and this position here is ARR 0, 0. Okay, this is two-dimensional array, but it's a fixed array, two-dimensional array. Okay, there are a total of 100 integers inside this array, and then the size of this ARR is 100 times size of integer. But I like to do something else. I like to do something like this. Okay, type def integer pointer, integer array pointer. So what does this do? Let's look at these two lines. Let's look at these two lines. Let's draw the picture. Picture is like this. Okay, M is an array of size what? M is an array of size 3, right? Okay, there are 3 elements in M, this array, and each one is a integer pointer, right? Each one is an integer pointer. What is the size of M? Okay, here, the size of M here. Okay, this array, it is 3 times size of integer pointer. Okay, 3 times the size of integer pointer. So after that, let's run this loop. It says that run this loop from 0 to 3, and each time call this operator new with an integer array of 4. So this is what I am going to do. Let's say I is 0. When I is 0, I get an integer array of size 4. Okay, and I will get the pointer to this one, and M0 will point to this one. Okay, this is M0, and this place is M00. Okay, when I is 1, again I will get another array of size 4, and this is going to be M1, and M1 is going to be pointing here, and this is going to be M1 0. Then I is 1, another M here. Okay, this is M2 and here. Okay, and this is going to be here M2 3. Okay, so this is the picture here. That's the picture for this one. Fixed size two-dimensional array. So which one would you prefer? This kind of a two-dimensional array or this kind of a two-dimensional array? Which one is better? Which one is better in terms of access speed, and which one is better in terms of memory usage? Which one is better in terms of access speed? A or B? Everybody take a vote. Which one is better in terms of access speed? By access speed, I mean this. Which one is faster? When I say ARR3, 2 is faster to access, or M2, 3? A is much faster, right? Why? Because when I say ARR32, I immediately know where it is in the memory. Just single access, I could do that in terms of access speed, right? For M, I need to go to this array first, find M2, follow this link, and then find the third element in it, right? So I need to do 2 accesses. Okay, so this one is slower in terms of access speed. How about in terms of memory utilization? Which one is more efficient in terms of memory utilization? For memory utilization, is A better or B better? Okay, some people say that it is B, some people say that it is A. No, the answer is A again. Because what is the size of this one? It is 100, right? It can keep 100 integers in it, because the array is 100 by 100, 10 by 10, total of 100 integers. Here I have 3 by 4, 12 integers, 4 here, 4 here, 4 here, but I have to keep 3 more integer pointers in M, right? So M is inefficient in terms of memory utilization too. So it looks like A is much better in terms of speed, access speed, and in terms of memory utilization. So why do I invent something like M in that case? Why do I do the multidimensional arrays in this kind of dynamic way? So what is the advantage of M? It is slow, it is inefficient in terms of memory, both CPU and memory. Why do I need this and why do I do the M? Oh, people they have lots of ideas. Is not A a double pointer? No, it is not. Well, I mean, you could use it as no, it is not a double pointer ARR. It is not. Long of second dimension. we can add randomly size all pointers. Okay, Hüseyin Ömer has we can change the memory locations freely. Yunus Emre, changing the memory locations freely doesn't make it any advantages for you, right? Why would you need that? I think Hüseyin Ömer has a good explanation. We can add randomly size all pointers. For example, I didn't have to say this is 4. I could have said new integer 4 plus I. What does it do? It says that, okay, for M0 the size will be 4. For M1 the size will be 5. For M2 the size will be 6. So it keeps changing. So usually when I do the two-dimensional arrays, I do stuff like this, right? I say that, okay, it's like a matrix. This is ARR 10 by 10. If this is what I want, is good. But for M in this case, it's going to be 3 elements in it, but it's going to be like that. I couldn't write it exactly. So just 3 elements, 4 elements, and 3 elements, 4 elements, and 5 elements. Okay, so like this. M is going to be like that. Okay, the first one, or maybe it was, okay, I guess it was like 4, 5, and 6. Okay, M0 is, in this case, M0 is 4 elements, M1 is 5 elements, and M2 is 6 elements. Okay, so that's the advantage of it. So we could have this kind of stuff, and in that case maybe we can save space even more. This is more flexible. Of course, after I am done with using this, I need to delete everything. So how would I delete it? Of course, I need to write code like for integer I from 0 to 3 I plus plus delete M I, then after that delete M. How many news did I have? 1 new here, 3 new there, and I am how many deletes am I going to have? 3 deletes here and 1 delete here. So total of 4 news and total of 4 deletes. Okay, so another multidimensional array discussion, and you try these. Okay, try to modify this, make new experiments yourself, do that kind of experiment, and the better yet, try to see the size of these and make very very large arrays and try to time it, your CPU times, how long does it take to create these arrays and use them and that kind of stuff. Okay, so of course with the classes it is possible to use this kind of notation. Okay, I have a money pointer, MP new money $10. Okay, and I could say the reference MP get dollars. I could say this, right? And I can print this out on the screen. Or better yet, maybe I could do directly cout MP, the arrow operator, get dollars. Then after I am done with this pointer, I just delete this MP money pointer. Okay, so no difference between the pointers of regular classes and the user-defined classes. Okay. With the classes, there is a new pointer. It's called this pointer. This, okay, this is a C++ keyword, like, okay, this is a C++ keyword, and it is used for pointing to the calling object. What do I mean by calling object? What do I mean by calling object? Let me give you an example. For example, this is a simple class. Okay. Inside the simple class, I don't have a private. I have an integer stuff, and I have a very simple function show stuff. Okay. Let me try to write some simple code. Simple S1. Okay. When I call this S1 dot show stuff, I don't like this. Okay. I don't like this show stuff definition, but anyway, okay, then no problem. Okay. Let me give you the implementation of show stuff. Void simple show stuff. Okay. Inside the show stuff, I can definitely say cout stuff. Why? Because stuff is my private integer. I can do that. Also, you could do this. Cout this. This is a pointer to this S1. Okay. This stuff doesn't make much sense in this example because I can already access the integer stuff here. But if you like to access the pointer of this S1, okay, if you like to access the pointer of this S1, then there is this pointer. Okay, this is a keyword in C++, and it points to the current object. I mean, to be able to call this show stuff, I need an object, right? So this is a pointer to this S1. This is a pointer to the S1. Sometimes it is going to be very useful when we overload some operators. Okay. Sometimes you need to talk about myself, right? I am writing a function of this class simple. I am working on an object. I forgot the const stuff. Sorry. Const. I am working on an object. Okay. And sometimes I need to access the object itself. I need to talk about the object itself. And we will see examples of it later in this chapter. Okay, so I talked about this pointer, and this is going to be useful when we overload the assignment operator. I think last week you looked at this assignment operator, but I am out of time right now. I think I will stop here, and tomorrow morning we will complete our discussion on this chapter. Okay, that's it for today.
Sir, that we are need to make it.
Did somebody ask a question? Did somebody ask a question? No? Okay.
Professor, I think that they have the question about the mid and Hüseyin Ömer asked about it.
Well, I think we will announce it this week. Okay.
Thanks, sir.